Hi, this is Dr. Nigro looking at our introduction to motion and the notes worksheets that we went through in class. First up, when we started this unit, it was all about what is motion. So we should start there with a description. All right, motion occurs when an object changes direction. Relative to a reference point. Relative to a reference point. All right, it's basically a description of the movement of an object. And that object can be anything, a person, a car, an atom, a molecule, whatever. All right. So with that definition in mind, we need to come up with some words that we can use to describe that motion. So we tend to use questions for that. Something like, how far does that object move? All right. How fast does that object move? All right. What direction does that object move in? All right. And then how long is that object in motion? All right. And each of these basically is a variable that we deal with when we talk about motion. How far tends to be distance. How fast? We can use speed here, or we use velocity. All right. What direction? We're either going to use actual directions like north, south, east, west, or we could use a positive sign to indicate up and a negative sign to indicate down. All right, and then finally, how long? This is time. How long is the object in motion? All right, so all four of these pop up in all of our calculations. So what does that formula look like when describing how fast an object is moving? Well, we're just talking about its speed, that it is in motion. All right, and we abbreviate this in our formulas with the variable s. All right, so that formula, speed, is the rate at which the object is changing its position. So we look at that in terms of distance covered divided by the time that it takes to cover that distance. All right, so we put our variable symbols in. Distance is equal to d over t. So it is the rate of our motion. All right, if we think about it in terms of units, all right, speed should always have units of meters per second. All right, we're in the metric system here because we're talking science, and we tend to be in meters when we talk about this motion. All right, which means distance must be in the meter and our time must be in seconds. All right, now this is a formula triangle, and some people like to use this to keep track of their formulas. You do not have to, it's just an option, but just so you can see, distance, speed, and time. So if we're looking at time, it's distance divided by the speed. If we're looking at speed, it's distance divided by the time. And if we're looking at distance, it's speed times time. So we get our three formulas. Speed equals distance over time, distance equals speed times time, and then time equals distance over speed. All right. Now, let's try using these formulas. As you're doing these problems, please keep an eye on your units. Make sure that your units match. So what does that mean? It means your time needs to be in seconds and your distance needs to be in meters so that you can find your speed in meters per second. All right. So let's see what we've got here. During your trip, you cover 805 meters in a time of 3.5 minutes. So we'll be working with speed, distance, and time. And for this problem, I know the distance is 805 meters. And I have a time of 3.5 minutes, all right? But I want that speed in meters per second. So I need to convert my time first, all right? Well, I know that 1 minute is 60 seconds. So if I multiply 3.5 times 60, I have 210 seconds for my time. All right, so now I have the correct units. I can use my speed formula, which is distance over time. Plug in my values, 805 meters, not minutes, divided by 210 seconds. And I find that I'm going to cover this distance at a rate of 3.83 meters per second. All right. All right, let's try another one. Later in the afternoon, you travel to a restaurant. How long does your trip take if you travel 3.8 kilometers at a speed of 15.6 meters per second? So again, speed, distance, and time. This time we're given the speed at 15.6 meters per second and the distance at 3.8 kilometers. And we're asked how long, and that how long is the time it takes us to make this trip. All right, so if we look at our units, we've got kilometers versus meters. So those don't work. We need to convert. So we convert those kilometers to meters. And I know that 1 kilometer contains 1,000 meters. So we actually have 3,800 meters. All right, with that conversion, we're all set to use our formula. All right, now if I look above, I can see that time is equal to distance divided by speed. So time equals distance divided by speed. I plug in my values, 3,800 meters divided by 15.6 meters per second. And I find that the time it's going to take for this trip is 244 seconds. All right, so that's just a couple practice problems using those formulas. All right, I like to organize my data this way, but you do not have to. That's just an option. All right. Now let's talk a little bit more about speed. So speed can be described in 3 ways. It can be described as constant. Whoops, sorry. Fix that. Constant. All right, it can be described as average, or it can be described as instantaneous. All right, so let's talk a little bit about what each of these mean. Let's start with constant. All right, if you say that an object is moving at constant speed, that means the speed does not change throughout the trip. All right. A great example of when you move at constant speed is if you're driving on the highway. All right. That tends to be the spot where you move at the same speed the entire time. All right. We can also discuss the average speed at which an object moves. All right. And that's just the average speed over the course of your trip. All right. To calculate this, we use a new symbol. We put a line over our S like this. And the calculation, we need to know the total distance that the trip covers and the total time in which it takes us to cover it. And that's going to give us the average speed throughout the entire trip. All right, and then last, we talk about instantaneous speed. All right, instantaneous speed is going to be your speed at a particular point during the trip. All right, it's not constant. It can be changing throughout that, but the easiest way to determine whether or what your instantaneous speed is to look at the speedometer in your car. All right, if you're driving down the highway and you glance down at your speedometer and you see that it reads 50 miles per hour, then that is your instantaneous speed at that exact time. All right, so let's look at one problem. All right, so this says you're driving to school from home and have to go through several stoplights. You travel a total of 5 miles to school and it takes you 0.2 hours. So what is your average speed during this trip? All right, so we're looking for the average speed, which means I need to know the total distance I cover and the total time it takes me to cover that distance. All right, now I'm going to leave this in miles and hours because we're not going to be doing conversions from the imperial system to the metric system, so we're just going to leave it alone for this example. All right, so our total distance covered is 5 miles, and it takes us 0.2 hours to cover that distance. So if I do that division, my average speed during this trip was 25 miles per hour. All right, so it says, is this the same as your instantaneous speed? Why or why not? All right, now the answer is no here. This is an average speed. So on average, we were going around 25 miles per hour, but I could look at my speedometer at any time and see what the instantaneous speed is. So our instantaneous speed is just at one particular time point. Now, that's not to say that it couldn't be 25 miles per hour at some point during our trip, but it doesn't have to be. Next, it says this is car driving at a constant speed. Why or why not? Okay, well, we were traveling from school and we had to go through several stoplights. All right, well, I know driving that when I see a stoplight, I have to slow down. All right, and when it turns green, I have to speed up, which means that I'm not going to be moving at a constant speed. So the answer here is no. All right, I'm going to slow down and speed up throughout my trip because of those stop signs and stop lights. All right, so we really need to keep track of whether we're talking about average, constant, or instantaneous. All right, if the problem says you are moving at constant speed, so let's say the problem says you were moving at constant speed, well, then that means that is equal to my average speed, because it never changes, and equal to my instantaneous speed. All right, because every time I look at my speedometer, I'm moving at a constant speed, so it should always read the same value. All right? All right, so that's really our introduction to speed. All right, come back to the next video and we'll talk a little about velocity.